Hey, trig functions of any angle, not just right angles anymore, but any angle.
That's the difference between this section and 4.2 is that now it can be above 90 degrees. It doesn't have to whatever. And so we have to kind of come up with a standard thing that we do so that we can all, like no matter who we talk to about these angles, we all know what we're talking about.
And we can get to the same thing mathematically correctly.
And also there's some really neat things that work out mathematically if we do all put things in the same place.
Yeah, so let's dive in, shall we?
Yes, let's.
Okay.
So we have an angle is made up of two rays, an initial side and a terminal side. That shouldn't be anything new. Here's
Initial's where you start, terminal's where you end, just in
Right.
case you're not sure on that.
Right, and here is our initial side fish. Oh, I'm sorry, that's an alpha.
Alpha, yes,
Yeah,
alpha.
okay. And then for simplicity in trig, we put angles into standard position, which means the vertex, which is this little point right here, is at the origin, 0, 0, and the initial side is along the positive x-axis.
So pointing off towards the number line that you've been using since kindergarten, we might as well keep it as simple as possible, right?
Right, right. So right here on this, the 0 degrees is over here where this x is, because this is the positive x-axis, and then we just move the angle so that that's its initial side and that its terminal side is wherever it needs to be.
Right.
So, and then there's an example of a positive angle and a negative angle. How do I know if it's positive or negative?
Here's how you know if it's positive or negative. If the angle that we're interested in is created going counterclockwise, you're going in a positive direction.
Right.
And if the angle you're creating is going clockwise, that's moving in a negative direction. Now, having said that, on both of the examples here, even with a positive and a negative angle, we could get the other one for both of those.
Right. And we're going to talk about that in a second, how angles really have multiple names that we could call them by.
Multiple.
Yeah. One thing that might help you remember which direction is positive and which direction is negative is back in the day we learned about quadrants like in Algebra 1 or Algebra 2.
Yeah.
And this we said was the first quadrant. This one we said was the second quadrant, third, and fourth. Well, and at the time that might have seemed like a weird way of numbering our quadrants, but now hopefully it makes sense because if 0 degrees is right here, our quadrants are coming around in the positive direction this way.
Right.
So that's one way that you can remember if you start to forget. So
there you go. Okay, so about naming those angles in 5,000 different ways, basically an infinite number of ways. And that's what's called coterminal angles.
Yeah. So let's just look at kind of an example right here. We've got this angle, and it doesn't really matter what angle that is. Remember, we start at 0 degrees. This
along the x-axis, positive direction.
Yeah. That would make this 90, 180, and then 270. And then up right here, if we keep adding 90, we would get
360.
360.
Mm-hmm.
Okay, so right here, this angle that's along the x-axis is 0 degrees, but we could also call it 360 degrees.
Or 720.
Because that's another whole revolution around. Right. And so that's what we're talking about when we talk about coterminal angles, is that we can have different numbers, but them end up being in the same spot. They have the same terminal and initial sides.
Right.
So like this angle right here, which I think I attempted to make be 135.
That's what it looks like to me, to the untrained eye.
We have 135 degrees, but then we could also talk about, well, what if we go all the way around the circle once and then come to this angle?
So you could have 360 plus 135
exactly.
and be in the exact same spot.
So that would be 360, yeah, like he just said, plus 135. And so what we do is we get these questions where they ask us to maybe find a positive angle and a negative angle that are coterminal with whatever they gave us. Well, if I have 100 degrees here, to get the positive one, we'd add 360 degrees.
Which would be 460.
Right, and then to get the negative,
we could just subtract 360. It's all in 360s. That gets you to the exact same point on a circle every time.
Right. So to do this, we added and we subtracted 360 degrees, and that gave us these two numbers. We could keep going, and we could find infinitely many more
angles,
as many as we wanted to, and just keep adding and keep subtracting 360. Yep. How about this 5 pi over 6?
Well, we don't want to necessarily mess with 360 anymore because now that's a really weird fraction to work with.
Well, and this is in radians.
And it's in radians.
Yeah,
and
we've
got to
put on our radian.
Yeah, we got to put our big boy britches on now and big girl britches.
So let's talk about maybe what these are like in radians now.
Yeah,
we have
let's do
0
that.
degrees. So
let me just ask you this real quick. What's the circumference of a circle?
2 pi r.
2 pi r. What if our radius is 1?
So that's 2 pi times 1.
Which is?
2 pi.
Which is how far it's going to count on this particular problem as well.
A whole circle is 2 pi.
All the way around one time.
So we're saying 2 pi and 360 are the same, which if you use your conversion, you should find that that's true. Also, we said a while ago that 180 and pi are equal because that's how we convert anyway. So now that leaves us with what is 90 degrees in radians?
Be pi over 2.
Right, and the way you can think of that is to go from 0 to pi, this is halfway.
Right.
It's half of pi.
Half of pi.
Okay, and then this would be
3 pi over 2.
3 halves of the way around the circle. Well, around the circle. That's never mind. Forget I said that. That's confusing. Okay, so anyway, what do we need to add and subtract to find our angles this time?
This time we're going to add and subtract 2 pi, which is the 360-degree equivalent in radian form.
Right, because you could change this to degrees.
You could.
And add 360, subtract 360, but you have to change your answer back to radians, and that's a lot of work. So if we want to add and subtract 2 pi, let's go ahead and get a common denominator for 2 pi.
Let's make it 6.
Let's put a 6 on the bottom, which means we times the top by 6 as well, giving us 12 pi over 6. That's what we're actually going to add and subtract to 5 pi over 6.
And this is going to be fraction adding like you did in 5th grade or whatever. It's no different, except now you're going to have a pi running around, and that is what looks different. But leave the pi in there. All the answers right now are not decimals. They're all pi's. And so when you're done, if you've got 5 pi's and you add 12 pi's, you have 17 pi's.
And that would be a great day if you had 17 pies.
Yeah. Apple pie, pumpkin pie.
Yeah.
Pecan
chocolate
pie. Chocolate
cream
pie. Oh, man. Lemon meringue pie.
Negative 7 pi over 6.
So there you go.
There's two angles we're going for. Right there. 17 pi over 6 and negative 7 pi over 6.
Bingo, bango, bongo.
Okay.
Hey there, let's check out evaluating some trig functions determined by a point in Q1. Q1, first quarter?
Quadrant.
Oh.
That's what we're talking about here, actually.
We're talking about maybe money.
No, we're talking about quadrants. Q1 is quadrant 1. So theta is the acute angle in standard position whose terminal side contains the point 46. Find the 6 trig functions of theta. Let's draw ourselves like a little picture.
You know, I'm just going to give a good rule of thumb here, I think. Always draw a picture, especially with trig.
Yeah.
Like if you don't draw the trig picture, life will be just brutal hard. And don't draw the picture in your brain either. Like actually put it on paper so that you can organize everything.
Put it on your paper. I would say that this is the point 46. Okay, so notice I went out approximately 4 and I went up approximately 6, and so we talked in 4.2 about how we draw the angle going down. We draw the triangle so it goes down and meets the x-axis.
Right.
Makes this a right angle.
Right.
And since x is our this way, then that means
left and right.
Yeah, left and right.
Yes, left and right.
That's 4, and up and down would be 6, and we get those numbers from this point because we had to go 4 out and 6 up.
Brilliant.
So we probably, since we need to find all 6, we should probably find the hypotenuse.
We're going to need that.
So what is that called when we do that? What is it?
Finding the hypotenuse?
Yeah, what is that?
It's called finding the hypotenuse.
You are so helpful. Pythagorean theorem.
Oh, that dead guy theorem.
16 plus 36 gives us 52.
I believe so.
Equals c squared. Square root both sides.
Now, don't square root both sides on your calculator either with these things. If you're asked to find all the trig functions, then you're going to simplify the square root of 52. Any answer given on something like this with decimal is not correct.
Right. We want exact values, which means square roots or fractions or both. Square root of 52. If you're trying to simplify this, I know it's divisible by 2.
Right.
And so I'm pretty sure it's divisible by 4. So what you should do is take 52 in your calculator, divide it by 4, and you get 13.
I think so.
So this is...
You could also do 52 divided by 2 and then divided by 2 again.
Right. You could do that as well. And basically, we can take the square root of 4, so we do. So that's 2. And we can't with 13. So square root of 52 is 2 square roots of 13. That goes on this side. Now we can find all 6 of our trig functions. So sine. And
super important now where that theta goes, though.
Okay.
Right?
Okay.
Like it has to be down there between the hypotenuse
the
and the
theta.
x-axis.
Yeah.
We can't just
right
pick
there.
a theta anymore like
No.
we did early on, right?
Yeah, yeah. This has to be
It's
theta.
got to be right
here.
there. It has to be, or
Okay.
it's incorrect.
Okay. So, and that tells us opposite over hypotenuse is 6 over 2 square roots of 13. And we can leave it like that. We don't have to rationalize. If you do rationalize, keep in mind you only have to times by the square root. You don't have to times by that 2 as well. And if you do times by the 2, that's fine. You'll just end up having to simplify.
Well, and 2 reduces with 6 as well, so that just makes it 3.
Oh, well, I should have done that in the first place.
You could do that too.
I should have probably.
But you didn't, and that's okay. Like, wait, okay, there was no need to do that.
Oh, well, I wanted to, okay. So this is 3 square roots of 13. If you're not rationalizing, that's your answer.
Right.
If you are rationalizing, it's 3 square roots of 13 over 13.
There you go.
Okay.
Bingo, bango, bongo.
And let's keep going.
Okay. Cosine is going to be the adjacent side then, which is the x-coordinate over the hypotenuse.
4 over 2 square roots of 13.
4 and 2 also reduce.
They do. 2 over the square root of 13.
And you should be able to reduce those. Like, you need to be able to reduce 4 and 2. Like, you should catch that.
Good call. Because sometimes it's really helpful to reduce.
Especially in the long haul, yeah.
Yeah. Tangent, 6 over 4.
Yes.
Which is 3/2.
Right.
Even if you do rationalize, we're recording right now. Oh,
What's up?
Okay. It's okay.
Well, there's like fewer days between Thanksgiving and Christmas, so I thought I'm just going to start early this year. Okay. Yeah, but I'm not playing the music yet, just the lights.
Just Elton John.
Okay, yeah, just Elton John.
Okay, sorry, it was Coach Allstat. Remember, cosecant and sine go together. We flip, and this is the place where we should flip.
Flip from the unrationalized part.
The simplified, unrationalized part. That's the easiest place to flip from.
Or you're going to have to re-rationalize, and that's no good.
No, that's a terrible, terrible thing to have to do on a daily basis. The only thing worse than rationalizing is re-rationalizing.
Because then you're re-rationing what you rationalized.
Exactly.
And then it's a mess.
Exactly. Okay, and here, like, let's flip this one. This
2/3.
This is 2/3. So, there you go.
There you go. 6 trig functions. Counting down, baby.
Example 3. Evaluating trig functions determined by a point not in Q1. Which quadrants are those?
All the others.
So 2, 3, or 4.
Yeah.
What does this change? That's what we want to look at. So I'm going to draw myself a picture. Look how straight my lines are.
Those are the straightest lines I've ever seen in my life.
Okay. -4,
I feel like
-6.
that's not quite perpendicular.
-4, -6 goes left 4 and down 6. So we're talking about an angle down here in quadrant.
Third quadrant.
Like this.
Third quadrant.
Yeah. So there's a point over here. This point -4, -6. And notice it's the same numbers, but now we've got some negatives going on. So we're basically looking at, all right, what does this change? Also, to draw this triangle.
Connect to the x-axis, baby.
Connect it to the x-axis. Never connect to the y-axis.
Never.
That's a terrible, terrible idea. Don't do it.
Yeah.
Go draw up or draw down.
That'd
That's
be like,
the only options.
If you connect to the y-axis, that's like something along the lines of Doctor Who not being able to solve a problem. He solves every problem.
Yeah, I don't understand what you're saying right now because he always solves the problem.
Yeah, so you can't. I mean, that's how you have to. It has to be that way.
So theta is right here. It's this angle that is closest to the origin between the hypotenuse and the x-axis.
Between the what axis? I didn't hear you.
The x-axis and the hypotenuse.
Every time.
And then the -4 is our adjacent side. The -6 is our opposite side. Now, the angle we're actually talking about here is an angle that stretches all the way around. Okay, but what we're doing is we're using a reference angle.
Right.
And we're just looking at this specific triangle in this third quadrant. What happens is because we're including these negatives here, that takes care of the fact that we're actually talking about this angle that's bigger than whatever the angle in our triangle is.
Right.
So that's kind of a weird thing that it's like, oh, well, it's neat that works out that way.
Yeah, it works out perfect every time. So it's really important to make sure that all of your numbers are correct.
Yeah, make sure your negatives are there.
With signage.
Yeah.
Oh, a hypotenuse on this.
Oh, so we did this one last time. And make sure if you're doing this that when you square, you put in parentheses because otherwise...
You're actually squaring the number -6, which means -6 times -6.
Which is positive 36.
If you do -6 squared on your calculator, that will give you -36, and that's not going to happen. Remember, when you're working with hypotenuse, that has to always be a positive number no matter what. It's a distance. It's a length. Like, we have to have a positive hypotenuse.
Absolutely.
Every
It
time.
was 2 squared root of 13,
I believe
right?
it was, yes.
Okay, so our hypotenuse is 2 squared root of 13. And notice that, or maybe you noticed, I don't know, maybe you don't. I can't tell if you can read that anyway. 2 squared root of 13. That number will always be positive. Our hypotenuse will be.
I just said that.
Did you really?
You just agreed with me when I said that.
I knew that. I was totally listening.
Thanks.
Opposite over hypotenuse is -6 over 2 squared root of 13. Did you really just say that?
Yeah, we can play back later.
Okay, I'm sorry.
Might as well not even sit over here.
No, please. You're great. -3 over the square root of 13?
That's what I probably already said also.
No, I don't think you did. Now you're just being a big baby. Cosine
But it's
of
the same
theta.
process, opposite over hypotenuse, okay?
Yeah,
And in this
adjacent
case, that
over-
opposite side is -6. Sine, SIGN, is super important here.
Right. The sine of the sine is sine of the sine.
That's going to be -2 over the square root of 13. Also negative because the SIGN
Yes.
is negative.
Yes. Tangent.
Yeah. Opposite over adjacent. Now pay attention here because something wacky happens.
By wacky, do you mean the negatives cancel
Yes.
out and it's positive?
Yes, it's wow. If we go back to what we were just looking at a minute ago, the tangent is identical. Like if you pause your notes, rewind, and look at the tangent on the other problem, it's the exact same.
Or if you look above where you're writing at the previous example.
Yeah.
Either way.
Yeah, like if you look in your notes,
Yeah.
those are going to be the same. And that's true. Like what we just wrote down for you that's a true thing.
Yeah. So secant of theta, no, that's not what I write next. I write cosecant. Sine and cosecant go together.
Yeah, sine and cosecant. You were one step ahead of the game.
Yeah. It was a close one. Cosecant theta. Flip this. Now when we flip, does that change the sign?
The sign has to stay there. It's still a negative. The only
Right.
thing we do is look at the reciprocal.
Right. That's something that people tend to mess up on, is they think when you flip it, you change the sign,
No,
and
you don't. You don't change the sign. Just reciprocal only.
So
Same thing on the
negative
cosecant, or same thing on the secant.
Square root of 13 over 2.
Yes.
That's a 3 right there. That's
Yeah, it's a
hard
3
to tell.
and a 2.
And then
And
cotangent
then down here,
theta.
2/3.
2/3.
There you go.
Now, at some point, maybe we should talk about the quadrants. You know what I'm talking about? Like
Yeah, I know what you're talking
sine,
about.
cosine, and tangent.
Yeah, do you want to talk about that now or later? I mean, you're already drawing it, so let's
do it now.
just do it.
Okay, so what happens is sine, cosine, and tangent, which all represent with S, C, and T, all 3 of those are positive in the first quadrant.
Right.
Okay, if you have an angle in the first quadrant,
Everything's positive.
everything's positive. Here in the second quadrant, well, if we look at, if we think about what's going on here with a triangle, okay, we have a negative for our x and a positive for our y. Okay, for a point that's over here. So sine, which is y over our hypotenuse, so positive.
be positive.
That sine will be positive. But cosine won't be positive because it's adjacent over hypotenuse.
And the adjacent this time is -x.
Right,
So a negative divided by a positive has to be negative.
Right, and then our tangent would be negative because it's y over -x, so that's a negative number.
Right.
Okay, so sine is the only trig function of the original 3 that is negative in the second quadrant.
That
So,
is positive in the second
yeah,
quadrant.
that's what I meant. That's positive in the second quadrant, and so is cosecant since they're reciprocals of each other.
Right, but all the others have a big old negative SIGN on
Yes, on quadrant 3, we did this problem right here. On quadrant 3, tangent was the only one that ended up being positive.
them. Right, and we just saw that one, so
Yeah. So in quadrant 4, what's going to happen is our x is positive, but our y is negative, and that means that
all the cosine stuff is going to be positive.
exactly. And there's a way to remember this because we have all in the first quadrant, we have sine in the second, tangent, and then cosine. Do you know this?
All students take calculus. That's how I remember it. How do you remember it? Do you have a different one?
Mine was all smarties take calculus, but I mean, They can just be students if you want them to be. Okay, either way, if you remember that, you have A, S, T, C, goes around in the quadrants. Those are the trig functions that'll be positive in that particular quadrant.
Yeah, there you go.
So if we were like, hey, what trig functions are positive between 90 degrees and 180 degrees?
You should be able to tell us.
Exactly.
Yes.
I think we're done here.
Okay, good talk.
Okay.
Hey, more trig function stuff. Festive winter light version.
Yes, so let's say to be any angle in standard position and let P of x, y be any point on the terminal side of the angle except the origin.
Whoa, no origin.
So not 0, 0, but any other point, we can let R denote the distance from P of x, y to the origin. So R is kind of like a radius if we drew a circle.
Yes,
yeah, maybe
right.
That's why they call it R.
That's a genius.
And so if that is the case, if we have a point out here, x, y, and we have this line drawn, then we have a side of a right triangle that's x, a side of a right triangle that's y. So R would be basically, this is just the Pythagorean theorem.
I feel like that's exactly what it is.
It is. And so then we can say these things. Instead of using our SOHCAHTOA or some old hippie or whatever, we can now look at this as sine theta equals y over r, because that's going to be the opposite side. Here, let me just write this. This is y and this is x, and this is a right triangle. Okay.
And this works no matter which quadrant you're in. That's the really cool thing.
Right, because what we're using is actually a reference angle right here, which let's call alpha since we've already got a theta. We're using this reference angle to talk about this triangle, but because, well, in this particular quadrant, like y would be positive and x would be negative, it takes care of the fact that it's actually a bigger angle than the reference angle.
It puts us right where we need to be with the appropriate side lengths.
Exactly.
Yeah.
So we've got these ratios here that'll help us out, and especially will help us with the, I would say, the quadrantal angles probably, which
I don't
think
even know. Is that like
next.
a tarantula, quadrantula?
Quadrantal. Is that how you say it? Have you ever heard of that word before?
What's that, like a quadrant?
I think it's coming up pretty soon.
All right.
Let's not ruin it.
Okay.
But if you want to refer to these at some point, it's basically the same thing as saying opposite over hypotenuse and adjacent over hypotenuse and all that.
Right.
Just
it's no
different.
Right. But
yeah.
But this is going to be super handy for what's coming. So the quicker you can get comfortable with x's and y's in these positions, the easier trig is going to be for you.
Notice that s and y go together, c and x go together.
Alphabetical order, maybe?
Yeah, yeah. If you put cosine and sine in alphabetical order, then x and y are also in alphabetical order. And that's pretty important to get the hang of as well. So
I agree.
Let's evaluating trig functions using reference angles.
Festive winter light version.
Yes. Find the 6 trig functions of 225 degrees. Why don't we start by drawing ourselves a nice little picture?
You know, I think every time we do a trig function, we should draw a picture.
It sounds like a reasonable thing because we're talking about triangles and we don't have a triangle unless we draw a triangle. Now, where... What did I say? I don't know. Okay. Remember, 0 degrees is over here.
Right.
Puts 90 up here.
Right.
180.
270 on the bottom.
270. Okay, that's going to be helpful because we need to figure out where is 225. 225 is halfway between 180 and 270.
How do you know it's halfway?
Because I did some math, like there's 90 degrees between it. If you half that, that's 45. And
180 plus 45 is 225.
Yeah, it just so happens that that is the case. So our angle is right here, 225-ish. And so what we're saying is that this angle to get around is 225. That's 225 degrees.
Yep.
But we're going to use reference angles, so that's not really the angle that matters.
No, it isn't. It's actually going to be how much further past the x-axis we went to get that angle.
We want to draw a triangle from the edge of our angle or somewhere on that line up to the x-axis.
Yep, that's what we want to do.
Up to or down to the x-axis.
Connect the x-axis and no other axis.
Yes. So now if this was 225 degrees to get around, we went 180 and then we went 45 more, so this is a 45-degree angle. Now, I think there's some special right triangles that
I feel like
since
you just drew the 45 in there, that yes, there are some special right triangle things.
I feel like 4590 has 1, 1, and the square root of 2 for sides.
I feel like what you're saying is correct.
Okay, but we're not in the first quadrant here. We need to definitely account for anything that might be negative.
I believe both coordinates in this case would be.
Yes, because we went left and we went down.
Yeah. Left and down, always negative.
Okay, so now that we've put those negatives in, that's why we're allowed to use reference angles, because the negatives account for the fact that we first went 180 degrees and then we went 45 more.
Yes.
So the 6 trig functions of 225 degrees.
Believe it or not, they're the same 6 trig functions as 45 degrees, but the signs are different.
Right, so we've got opposite over hypotenuse.
Which would be y over r.
Right, if you, whichever way you want to think of it. And normally with the special right triangles, we do go ahead and look at those rationalized. So wouldn't you say that's the case?
Mathematicians everywhere typically write them like this.
Yeah,
although you're not incorrect with
2.
1 over square root
No,
of 2.
you're not.
Those are both acceptable answers.
Cosine of 225.
This would be x over r.
X over r, so negative 1 over the square root of 2. Which is, again,
the exact same thing.
And that should always happen with 45, 45, 90 triangles. Tangent of 225 degrees.
Which would be y over x.
Y over x, which is negative 1 over negative 1, which means it's positive 1.
What?
Yeah.
What?
Cosecant theta. No, why did I put theta? It's 225. We totally know what it is.
I feel like you wanted to color.
Maybe. Flip sine. Flip from right here, so that should be negative square root of 2.
Yep.
Secant negative square root of 2.
Yep.
And cotangent, which we flip 1, and it's 1.
That 1's an easy flipper.
Right. And then we talked earlier in the video about all Smarties take calculus, or all students take calculus, and sure enough, our tangent was the only thing positive in the third quadrant.
Negative divided by negative,
tangent,
always a positive.
Tangent and cotangent. So sine of negative 150 degrees.
Festive Winter Holiday Light Edition.
Right, without a calculator. So let's draw ourselves a picture.
Always draw a picture.
Here's our quadrants and a negative 150 degrees. So 0 is here. Negative 90 would be here.
Going the other way. Going the other way this time.
Negative 180 would be here. So how far past 90 do we have to go to get to 150?
60 degrees.
60 degrees, which means we'll have 30 left over. So 60 degrees past negative 90. It is kind of helpful. Like, normally I don't make a big deal about like drawing to scale because I feel like it, stunts my creativity. But with 30, 60, 90 triangles, it is kind of helpful.
It's a little bit on the beneficial side to have those
bit.
Angles halfway close to what they're supposed to be.
Yeah, because then it's really easy to tell, since we went 60 this way, okay,
That's
is 30.
got to be 30, right.
Right here. And we went negative 150 to get there, so.
Hey, I think you connected that terminal side of the angle to the x-axis. Am I correct?
I did, and that's what we always do.
You didn't connect it to the y-axis.
No, we never want to connect to the
y. Just double check.
Always go up or down to the x-axis.
Right.
And so across from 30 degrees is 1, which, hey, that looks like the smaller side. It's negative 1 since it's going down.
Right.
The hypotenuse is 2. We've got negative square root of 3 over here. And
how did you know that was a 1 that went down like that?
Because it's a special right triangle, 30, 60, 90. 1 square root of 3, 2. The 1 is always across from 30 because our angles like match up and stuff. The smallest angle is across from the smallest side. Thanks. I don't know if that was a compliment to me or to math. I'm going to say you complimented both of us.
At one time.
We both appreciate it.
Okay.
All right, sine is opposite over hypotenuse or y over r, depending on how you want to think of it.
Get comfortable with y over r, kids.
So negative 1/2 is sine of negative 150 without a calculator.
Wow, you're a genius.
Thanks. Okay, so let's
4 pi over 3.
4 pi over 3. Now we're getting into this like, I was going to use the line drawer thing, and then I forgot.
Yeah, that's okay. But that's a fairly straight line if you can ignore the squiggles.
I thought it was pretty good. Yep. Okay, 0 degrees is over here, but I didn't mean to put degrees.
Not
we're
degrees.
In radians.
We're at 0.
Okay, but it's not a big deal since they're both 0.
Right.
Pi is over there.
Yes, pi right there. There's a pi.
Pi halves.
Pi halves.
I mean, 1/2 pi is better to think of it.
And then 3 halves pi.
What you need to think of is it's 1 pi to get from here to here. And so if we're talking about thirds of pi, like we end up with with being able to like break this up into thirds, you know, that kind of thing.
Right.
Which those aren't quite to scale, but like that's what we're talking about whenever we look at 4 thirds pi. We're trying to go more than 1 pi.
More than one. How much past 1 pi are we going?
Well, I believe we're going 1
1/3 past pi?
Yes, because 4 thirds is 3 thirds plus 1/3.
That is amazing.
So we're going 1/3 past
So
pi.
we're 1/3 past pi.
And so that's going to be about right here.
That is excellent.
Okay, and the sooner that you can get the hang of like, it is helpful to think of what this is in degrees, like at least as far as the reference angle goes. If there's a 3 on the bottom, our reference angle is going to be 60 degrees because 3 times 60 is 180.
Shut the front door.
All about that conversion of pi and 180 and all that stuff. So
that's a genius trick.
This is 60 right here inside of our triangle.
Well, how can you tell if
right
it's
there.
a 30-degree reference angle if what's on the bottom?
Well, if it has a 6 on the bottom, then it should be a 30-degree reference angle.
Why?
Because 6 times 30 is 180.
That is insane.
Yeah, or, you know, really logical depending on, you know. So this is a 30, 60, 90 triangle, so we've got our sides here just like up above.
Wow, exactly the same.
It's turned. Because
the hypotenuse, though, stays the same.
Yeah, the hypotenuse stays the same, but now we're talking about 60 degrees instead of 30.
30 degrees.
And tangent is opposite over adjacent, so that's negative square root of 3 over 1. I'm sorry, y over x is what I meant to say.
Y over x.
And that gives us, sorry, they're both negative. That gives us positive square root of 3.
Bingo, bango, bongo.
Okay, secant of negative 5 pi over 4.
You had me at secant.
Secant. Why did I have you at secant?
Look at that word. How fun is that?
I like that as
It's
a word.
a fun word.
It's a neat word,
Yeah,
I guess, as far as words go.
Yeah.
All right, so let's think about where negative 5 pi over 4 is.
Secant.
That sounds kind of negative when you say it like that. I prefer to see can. No, like I see that we can do this.
I see that too.
Okay, so negative 5/4.
Okay, now hold on. I'm going to try. Okay, let's see. 5 pi over 4. That's going to be 1 pi over 4 spot past 4 pi over 4.
Right, because negative or 5/4 is 1 and 1/4.
Yes.
Yes, and we're going in the negative direction, so we are
going upside down.
We're going 1, and then we're going 1/4 of the way past it.
1/4 past the pi.
This is half, so this is 1/4 right here in this quadrant, right here, over here, and it's. I mean that's
1/4. So 4 pi over 4 plus pi over 4 is 5 pi over 4.
You can't really tell, but that's a 45 degrees. So again, 4 times 45 is what gives us 180. So every time there's a 4 on the bottom, our reference angle is going to be 45
That's crazy.
degrees. Or really helpful. I mean, it's whatever. -1, +1, and the square root of 2. Remember
okay.
the hypotenuse is always
positive. Right. Always.
We both agreed separately that that's the case.
I don't know why you would bring up stuff like that.
I don't know.
I was clearly right that one time.
Yeah. You were.
So the secant then of this is going to be the reciprocal of the cosine, which happens to be x over r.
So we want r over x.
R over x it is.
So square root of 2 over -1, which is negative square root of 2.
Blam! Look at that.
Perfect.
Trig functions, no calculators.
All right, later.
Hey there, kiddos. We're going to use the find the following if it exists rule here.
Okay, if
Festive Winter Holiday Light version.
Yeah, if the value is undefined, write undefined. That makes sense that if it's undefined, we should write undefined.
I think if it's undefined, we should just write 0, right?
But that's not the same.
Yeah, I agree.
Zero is like an answer. Like if you have like 2 minus 2, you put it equals 0. You don't put it equals and then not write anything.
But what about 1 divided by 0? People write 0 all the time.
Well, that's wrong because you can't take 1 of something and divide it into 0 groups.
I agree.
So it's undefined.
It has to be undefined, okay?
Okay, so
good talk.
These angles in this particular example are what we call quadrantal angles because they happen to line up with our quadrant lines, which like our x and our y axis.
These are going to be the ones you're going to love as we get going.
because they're super easy if you understand what's going
Right.
on. Where is negative 270 degrees?
Straight up.
Right, because if we count around, oh look, negative 270 is up here. Hey, isn't that the same as positive 90 degrees?
I would, yes.
Okay, so we can't draw a triangle if we're talking about an angle that's straight up and down here. But what we could think about is the fact, well, you know, our x, we went 0. We went 0 for x.
I'm coming apart.
Okay, we went 0 for x, but we could say that we went, I don't know, we could say we went like 10 for y.
10 indeed.
We could say that y here would be 10, and then if we think about what that makes r, if we do a little Pythagorean theorem action.
Halfway, Pythagorean theorem.
Halfway?
Yeah, because, I mean, there's,
well, but
you get one of them 0, so you only have like half of it.
Right, so the 0 goes, and it's just, oh, r would be 10.
Whoa, 10 divided by 10. I know what that is.
Okay, well, but we don't, we need to figure out what sine is. So we don't need 10 divided by 10. Sine is y over r. So, oh, no, you just said that. No, I'm sorry. I thought you were trying to do like a, I don't know.
It hurts when I'm right, Mrs. Stevenson, and that's okay.
I feel bad because I'm
2 days in a row that you've dissed me, but that's all right.
Okay. Sine of negative 270 is 1.
Going to be on YouTube later.
Yeah, well. Tangent of 3 pi.
3 pi. I know right where that is.
Really?
Yes.
How?
Well, because if I go to pi, then that's going to be over there on the left.
Right, on the left is
yeah,
pi.
And if I go all the way around the circle one time, that's 2 pi's.
Right.
My lights just went up. My festive winter holiday lights just went out.
And
so
then,
if I go one more pi past all of that.
Oh, hey, that's over here.
That would be 3 pi.
3 pi. So over here, we're talking about this angle that's along
the x-axis in the negative direction.
Right. So what we can do is we can say that our x here is, we went negative something.
Yes.
So
10.
Negative 10, sure, why not? And we went 0 for our y value, and that makes r be, would that be positive or negative 10?
Well, you know, r has to be positive, so.
Yeah, so it'd be positive 10. So tangent is y over x. Our y is 0. Our x is negative 10. Right?
I think so.
Right.
That's what we were saying all along.
0 divided into negative 10 groups, you would have 0. So
right.
That answer is 0.
Fabulous.
Yeah.
Tangent
fabulous.
is 0.
Fabulous.
I really like that net around your head, actually.
Thanks. I was going for like a nun cowl of lights.
It's festive winter
think?
holiday lights.
Yeah.
I like it.
Yeah. Okay.
It looks good on you.
Let's find.
I know right where 11 pi over 2 is.
Do you?
Yeah, I think so.
Okay. Do you think it's helpful here to actually change this to a mixed number?
You know, I think it's got some potential.
Yeah.
To do that, yeah.
Some potential?
Some potential.
Is that what you were going to do?
No, I was actually just going to count it off the first time and see if I got to the right spot.
Okay, what do you mean count it off?
Well, you start off and straight up you got pi over 2. And then you go all the way around to the bottom, and that's 3 pi over 2. So I added 2 on top. So if I add 2 on top again, that's 5.
Oh, I see what you're saying.
And if I add 2 again, that's 7. And if I add 2 again, that's 9. And if I add 2 more, that's 11. That's what I was going to do for the first time.
I see.
Now, there are some other ways to do that. But
right.
for the first time while we're
11 pi over
investigating,
2.
that's how I was going to,
So that's down
it.
here. So,
straight down.
So we've got for our x value, again, we've got 0. For our y value, we've got like negative 10 or whatever you want to use.
Right.
We just are picking negative. We're just
it could be 5,000.
Whatever.
Negative 200
the
million.
The whole point is that whatever value we have that's not 0, that's what r has to be, but positive if it's not already positive. That's the whole point there. So secant is r over x.
Well, the secant is the reciprocal of cosine. So yes, r over x.
So r is 10. X is 0.
Oh boy.
10 over 0. You can't divide by 0.
Just write 0 there, kids.
It's undefined.
Nope, you just write a 0.
Okay, and what?
Just write 0.
No.
Right? No what?
No, undefined.
No, but I don't.
Would
okay.
you listen to me? It's undefined. If you divide, you cannot divide by
Don't,
0.
look, that is
ever.
trig. That is trig mistake number 1 to write down that this is equal to 0. I'm telling you, and Mrs. Stevenson is telling you, don't do it. It is
undefined.
It is undefined.
Example 7, using one trig ratio to find the others.
Best of winter light holiday.
Addition. Yes. Find cosine theta and tangent theta using the given information to construct a reference triangle. So what we're going to do is not use our calculator because they gave us plenty of information for us not to have to. Calculators just make us round unnecessarily. Yeah. So we draw
approximate
a triangle.
answers instead of exact ones. And by the way, this is where fun trig actually takes place.
Yeah. Yeah, I know. It's so fun. So fun. Where is sine positive 3 over 7? Remember that's y over r. So the y value is positive. R value is always positive. So we've got a situation like here in the first quadrant where we've got, what are you doing? Why do you keep messing with the lights?
My lights quit working.
We've got 3 for our y value, 7 for our value. But that's not all.
If you act now, you can also get a positive 7 value and a positive 3 value in the second quadrant.
Right, over here. There's another place where we get that positive 3/7 ratio, okay, because there's 2 places where our y value could be positive. And if you think back to all Smarties take calculus, all of the trig functions are positive in the first quadrant and sine is positive in the second quadrant. Every single time that we do this where we have a trig function equaling something, we can make 2 triangles. So they have to give us more information, which they did, in order for us to narrow down which one it is.
Yeah, now here's the deal. They told us that the tangent has to be negative, and there's actually
That's what this means, less
two
than theta.
quadrants less than 0.
Yeah.
Yeah.
Oh, sorry. There's 2 places.
There are 2 places where that can happen.
Yeah.
So
it's tangent's positive in the first and the third quadrant.
And it's negative in second and fourth.
So gets rid of these 2 quadrants as options. Sine
that leaves us
down there.
Nope, it
has to be
it's
that
gotta
triangle.
be. That's the process of elimination. We're going to use good old-fashioned Sherlock Holmes thinking.
Yeah, so we need to do some Pythagorean theorem real quick to get the third side. So 7 squared minus 3 squared, which is square root of 40.
I believe that is correct, yes. So b squared equals 40, so b equals 40. So root 40, yeah.
Which we can simplify. That's 2 square roots of 10.
How do you do that so fast?
Because I think 40 is 4 times 10, square root the 4 and get 2.
Do you teach math during the day?
Sometimes.
Man, you should really think about that.
2 square roots of 10. Now, is that a positive 2 square roots of 10 or a negative 2 square roots of 10?
Since we're going to go, we're looking for the x-coordinate in that left-hand direction there. And my kindergarten teacher, Mrs. Barnes, always said lefty was negative.
In kindergarten?
Yeah. Well, I was a super genius. So yes. No, not in kindergarten. Whenever I learned it, in probably, 12th grade or something.
All right, negative 2 square roots of 10 is that third side.
Yep.
Now we can do what they asked us. And
find the cosine
and
and
tangent.
tangent. Yep. Now for these, we just go back to the whole cosine is the x-coordinate over r, which we just found the x-coordinate.
Yeah, negative 2 square roots of 10.
Over r, which is 7. So there's that bad boy. The other thing that we're looking for is the tangent of theta, which is going to be the y-coordinate over the x-coordinate. So 3 over negative 2 square roots of 10. And I'm pretty happy with that answer.
I'm happy with that answer.
But if you absolutely insisted on rationalizing it, you could get 3 square roots of 10 over 20 with a big old fat negative in the front.
Because we multiply the top and the bottom by the square root of 10.
Right.
So we end up doing 2 times 10 on the bottom and get 20, and we just put those
That's how it
together on
goes.
top. All right, so B, secant theta equals 3, where sine theta is greater than 0.
So again, we're going to use our cool Sherlock Holmes process of elimination.
Also, it's helpful to remember that 3 over 1.
Oh, yeah.
I mean, 3
yeah.
is 3 over 1.
Yes,
because
that is
we've
correct.
got r over, this is related to cosine, so r over x.
Right, r over x.
So our x value is
R! Okay.
Are you a pirate?
I am not
Okay.
a pirate. Maybe for today. R!
Okay, so x is positive this way.
Yes.
where we've got a positive 1 right there, and we've got a 3 right there.
And in fourth quadrant.
And in the fourth quadrant. They actually share that side there. It's kind of
Shut the front door. Look at that.
neat.
They share the side.
Yeah, yeah. So we have to figure out which one of those we're talking about. Sine has to be positive, and sine is positive
Only in the first
and
quadrant.
second quadrant,
Yeah.
but they overlap in the first. So that's the one we want, is the one that's in the first quadrant. So we need to find the third side. Now, some of you may be inclined to put square root of 2 here.
Don't do that. That's a lie, vicious lie.
We need to find, using the Pythagorean theorem, we need to find it.
Yeah, and if you'll notice right here, if you'll just take the whole 25 seconds it takes you to run through Pythagorean's theorem, you're going to see there's no square root of 2 in this one.
Yeah, 3 squared minus 1 squared is 9 minus 1.
That's 9 minus, it's 8.
So square root of 8, which is
2 square roots of 2.
2 square roots of 2.
But not just the square root of 2. Okay.
No, no.
So 2 square roots of 2, there you go. Bingo,
Okay,
bingo,
1,
bongo.
2 square root of 2, 3. So cosine is x over r. Oh,
Okay,
which we actually didn't need the triangle for.
Yeah,
We
that's
could've just
1/3.
flipped-
That's right
we
off
could've
the
flipped
bat.
secant.
That's okay.
Anyway, we needed it for tangent.
Yes, and the tangent in this case is going to be the y coordinate over the x coordinate.
So that's 2 square roots of 2 over 1, which is 2 square roots of 2.
There you go.
Cotangent theta is undefined, and secant theta is negative.
So when I hear that something is undefined,
What
I
does
feel
that
like
mean?
there should be a 0 someplace.
0 on the denominator?
Yes!
So-
That's yes.
so we're
0 on the
saying
denominator.
That our what is the ratio for cotangent? X over y?
Yes.
So our x has to have some value, and our y is 0. And we need to draw that picture. This will be a quadrantal angle. That's the only place we end up with undefined.
Right.
Right?
And we're going to be undefined when we are along the x-axis in this case, because y would be 0.
So y is oh, okay, I see what you're saying. So either we're going this direction,
Yes.
or we're going this direction.
Yes. I agree to both of those.
Okay, so secant theta is negative.
Now secant is 1 over cosine.
Right, and so that's talking about our x value would have to be negative. So that means we're looking at this direction, the one on this side.
Which would be?
Well, we could start trying to think of this as like a point -1 comma 0.
Right.
Okay, where that's our x and our y value, and then our r value would be the length of this line, which since we went out 1, our
would
r
be
value
1.
is 1.
Yeah.
So then cosine is
-1.
-1 because it's x over r, and tangent,
Would be 0 because that's going to be the reciprocal of the cotangent.
right, because if it's undefined we have a number over 0, and so now if we flip it, it's 0 over a number, which,
Right.
yeah, 0. Yeah,
Game over.
totally. You know.
Okay.
Oh, periodicity.
Periodicness.
Periodicness. Periodic functions. Hey, it turns out that these trig functions are periodic.
I like that word, periodic, because it means it just keeps happening
Over and over
on a
again.
schedule,
Yeah,
over and over
like-
and over and over and over and over.
Like
and
when
over.
we keep drawing this whole 0, pi, 2 pi, blah, blah, blah.
3 pi, 3 pi,
Like the
4
fact
pi,
that...
4 pi,
4 pi, okay, and we
5 pi?
we could keep going, but we're not going
5
to.
pi?
We could.
Okay, all right.
Okay,
Good talk.
so what happens is that sine of 0 is the same as sine of 2 pi, which is the same as sine of 4 pi, right?
Yes.
Right?
Yeah.
Like whatever.
They give you the exact
They
same
give you the
answer
exact same
every time.
thing, this direction. And so sine and cosine both have a period of 2 pi, and we'll really dive into that next section. Then tangent actually is weirder because it actually has a period of pi over 2, and we'll look at why that
Pi.
is.
Period of pi.
Oh, yeah, it's half of the...
It's half of the big dog. That's okay. It's
Okay.
Mistake number 2,
Okay.
all on the same day, but we
Okay.
won't talk about it.
So tangent of 0... Tangent of 0 is tangent of pi, which is tangent of 2 pi.
Which is tangent of 3 pi.
And if you look at, like a unit circle, which you may or may not have heard of before.
The unit circle, I love the unit circle.
If you look at what it is at 0 and then pi and then 2 pi, if you keep going around, those are the same values. Because of the fact that because tangent has the first and third quadrant that have the same signs.
Right.
Yeah.
They start to repeat a little quicker.
Yeah. So let's use this idea of periodicity to find each of the following numbers without a calculator.
Whoa, look at that. 57,801 pi over 2.
That's a lot of pi's.
Whoa.
Over 2. What if...
I mean,
What if we made this into a mixed number real quick?
Knock your socks off. Just go right ahead.
All right, so 2 with the 1 left over, 8 with the 1 left over, 9, nothing left over, 0, 1 left over. 28,900 pi's plus a half pi.
I know right where that is.
I do too.
Pi over 2.
Because
that's an even pi right there.
Even
an
pi.
Even pi is over there.
Oh, yeah, all of our even pi's are on the same
Son of
side.
a gun.
All of our odd pi's are on this side.
It's like they're periodic.
Even pi's, and then you add a pi over 2 to that, so that means we're up here at pi over 2.
Right.
So let's think of this like the point, I don't know, 0, 1.
That is a brilliant point to choose. What made you pick that one?
Because it's so easy to use 1.
For a radius.
Yeah. So 0, 1
what is
with
going on around here?
With a length of 1, which means that sine, which is y over r, is 1.
So, let's do another one.
Now,
can we do another?
Yeah, let's do another. We have cosine of 288.45 pi minus cosine of 0.45 pi. Okay, so here's I think what's important. Like, how far apart are these two angles?
Okay, hold on. Don't tell me. 8.
Okay, so what we could do is we could rewrite this first angle as 280.45 pi, that's the second angle, plus 8 more pi's. Okay, and the reason that this is important is because if we're talking about them being 8 pi apart, these are the same values.
Get out of town.
Because 8 pi divided by 2 pi, that divides evenly. So that means that basically whatever this first angle is, we're going around the circle 4 times, and then we're back at the same spot.
I feel like this is like there's been a light that's turned on. Yeah,
just one or a lot?
Maybe more than one.
Okay, so this would give us
Maybe
some
they're
value.
winter holiday lights.
But we would get the same value. If we're getting the same value both times and we're subtracting, this would be 0.
You're mind blown.
Yeah, I thought so.
Wow.
I thought that would happen.
That's just crazy.
C, tangent of pi over 4 minus 99,990.
I know. I think I know right where that one is.
Okay.
I think it's going to be over. It's going to be like just the exact same thing as saying pi over 4 minus pi.
Okay, because all our even pi's are on the right
side. So all the odd pi's have to be lefties.
Left. So, and it doesn't matter that it's negative really if we're just talking about pi, because we have negative. We can make all these negatives and that still works.
It's not a problem.
So you're saying, now which way should we go for pi over 4? Like,
the
positive direction, right?
I mean, it says positive pi over 4 there, so yes.
So yeah.
So start from there, go there, yes.
Right.
That's exactly what I would do right there,
here.
yes.
So that's a 45, 45, 90 triangle, and gives us -1, -1.
Which is 1.
2. So tangent is 1.
Jeez.
That's how you use periodicity to find trig functions.
Periodicity?
Incidentally, if you were to type these into the calculator, you may not get those answers. Even though 1, 0, and 1, those are like normal answers. It's not like, oh, I got this weird fraction. Like, if you try to, at least on A and C, if you try to type those in, your calculator may not actually give you the correct answer.
I don't believe it.
Well, try it yourself. I'm just saying what the book told me. The book said, hey, try it and see. You might not get the right answer. And that has to do with the fact that we're using such big numbers, I think. And
it has a rounding error.
And there is a rounding error, perhaps.
That is very interesting.
Do you know how... never mind. Never mind.
Okay, good talk.
Yeah. Bye.